Hello there. Today we're finding powers and roots of complex numbers in trig form. Remember, complex numbers, when they're in standard form, have a real part and an imaginary part. But when they're in trig form, they have a number outside of parentheses called the modulus, followed by a set of parentheses where you'll find cosine of an angle plus I sine of an angle. And that's called trig form. The reason we use it so often is we can raise numbers that are complex to powers and roots very quickly in this form, where it's quite miserable in this form. So an example of a number in trig form might be 4 cosine pi over 6 plus I sine pi over 6. And this is always this is a real number out here, and in here we have an angle, and those two angles are alike. So if you recall, to get from this form to this form, to get from the standard to the trig form, you use Pythagorean to get the outside number. It's the distance from the origin, it's always positive, and to get the angle you used an inverse trig function, such as inverse tan. Alright, we're going to look at how to take a number that's already in trig form and raise it to a power. So I'm going to make up one, let's say 2 cosine 30 I sine plus I sine 30. We'll work in angles for this one without the radian measures. We'll work in degrees, I mean. And let's say we're going to multiply, or we're going to raise that to the power of 3. So what that means is this number times itself times itself. So let me do that out. So we have this number once, and then this number twice, and then this number once more. If I can smusheroo here, cosine 30 plus I sine 30. Okay, so as you suspect, when you raise something to the 3, it's that something times itself 3 times. If it had been a 4, I would have 4 of these, 5 of these, and so on. So step by step, which you can probably tell will be the last time I do it this way. We've learned how to multiply two complex numbers in trig form. You multiply the modulus numbers, 2 times 2, and you add the angles. So this one would be a cosine 30 plus 30. And we had some practice in class, hopefully, today with that. So that's the answer to that one. So now I have to drag this one down and add it to the mix. So what is the product of this answer, which was the product of these two, and this one? So again, we multiply those outside numbers and add the angles. So 60 and 30 are 90, and I could go further simplifying with that, but I'm going to leave it in trig form. Alright, so now how could I have very quickly gone from the original problem straight to the answer? Sort of chutes and ladders. Remember when you landed on that spot, it was bad news. Well, this is going to be good news. Alright, so we're going to find a way to go straight from the problem to this. You can probably see the connection. So let's say we don't know the answer. So this is erased from your view. And I want to take 2 cosine 30 plus I sine 30 and raise it to the 3. So what I'm going to do is take the number, the modulus, and raise it to that number, 2 to the 3. And I'm going to take the number here. Look, the 30, when we raise this whole complex number to the third, we ended up with a 90. So how could we do that quickly? You can see, I'm sure. So we have cosine, and when we get to this spot, we're going to take the angle and multiply it times the power that we're raising this number to. Alright, so you can see from that we're going to get 8 cosine 90 plus I sine 90, which is what we got down here. Alright, so let's see if you can do one. Let's say we have a bigger one, like 2, like a bigger power. So 2 cosine 30 plus I sine 30 again, but this time let's raise it to the 10th. So imagine if I was doing this without this theorem. I would have to multiply this times itself, like we did here, then that answer times itself, and that answer times itself, and that answer times itself 10 times. But with this theorem, I can do it in one easy peasy step. 2 raised to the 10, and then 30 times 10. Alright, I don't really need those parentheses, but I'll put them in there to match. Alright, so 2 to the 10. I believe it's 1024, forgive me if it's not. And then this follows cosine 300, I sine 300. Always check and see if this number is greater than 360 and reduce it back down. But ours is fine. I'm going to leave it in trig form. So that's how we go from the problem to the answer quickly. Alright, that has a name. De Moivre's theorem. There's an R in there that you can't hear, French name. De Moivre's theorem. So please give honor to him by writing it down. And also, on De Moivre's theorem, I'm always kind of amazed that he had a whole theorem named for himself, where we probably could have thought of this ourselves. So once we knew how to multiply numbers that were complex in trig form, it wasn't a big stretch to get from here to here. So he got a whole theorem named for him for that. So go figure. Alright, I'm going to shut this down and do part 2, and I'll be right back with you.